All right, everyone. So this video is to go over that enzyme graphic organizer that many of you guys did in class. This is a great resource to review for your test coming up, and it's also a great way to make up work if you were absent. So first thing we're going to do is talk about what is an enzyme and what role does it play in cells. Well, an enzyme is a type of protein, okay? So an enzyme is a protein that speeds up chemical reactions. So how specifically does it speed up chemical reactions? Well, it speeds up chemical reactions by lowering the activation energy of that reaction. A few things I want to point out. First of all, an enzyme is a protein. It speeds up chemical reactions, also known as a catalyst, and it speeds them up by lowering the activation energy of a reaction. Okay, so those are the big things. So let's now go into what type of macromolecule is an enzyme. Well, it's a protein. So if you had one of those sorting questions on a test or assignment, you know that this type of macromolecule is a protein. So let's break down how exactly this works. An enzyme substrate complex is much like a lock and key. Okay, so this is going to be labeled the substrate. This is the active site, or like that keyhole. And this here is the enzyme. So the substrate, this is the reactants. The active site is how the substrate binds to the enzyme. Okay, so what are the reactants of an enzyme catalyzed reaction called? So what are the reactants? Well, all the reactants are exactly what I said right here, a substrate. So the substrates are the reactants of this reaction. Okay, reactants, remember, are what goes into a reaction. Products are what is produced or what comes out. Okay, so where does the reaction between the enzyme and the substrate take place? Well, the actual reaction is going to take place in the active site. Think of activity as in the active site. Think of site is the location where it occurs. So the active site is where this reaction between the enzyme and substrate take place. And what are new molecules released by an enzyme called? Well, those are the products. So when we are talking about a reaction, remember a reaction has reactants, that's what goes in. The reactants are the substrate. Where does it occur? The active site. And what is produced? That is called the product, okay? Or those new molecules released by an enzyme, okay? So remember, the substrate is like the key, the active site is like the keyhole, and the actual door is like the enzyme, what's actually making it happen, all right? So why is an active site and substrate often referred to as a lock and key? Well, let's talk that through. I know I just went over that picture, but the active site is shaped only so that the substrate can fit into it. Let's break that down. So the active site is like a perfectly made keyhole that only the substrate can fit into. It is personalized for that. It is uniquely made for that, okay? And enzymes can only catalyze one specific reaction. And this is because its active site only fits with one substrate, like a lock and a key. So think about that. You've got a house key, you've got a car key, you've got maybe a key to a shed or a garage, you've got a key maybe to a bike lock, okay? Those are all different shapes and sizes and have a different role to unlock different things. The enzyme and the substrate active site combination works very similarly to that, okay? So the active site is shaped only so one substrate can fit into it. And enzymes can only catalyze one specific reaction because its active site only fits with one substrate, like a lock and key. I forgot that word, like a lock and key, okay? So let's break this down. What is the role of a catalyst? Well, catalysts speed up reactions. And it does this by lowering the activation energy. And catalysts can be used over and over again to catalyze their specific reaction, okay? We're going to go over specifically, though, what the heck is an active site and what am I talking about, okay? A really important thing to note, though, is all enzymes are catalysts, but not all catalysts are enzymes. That's really important. There are other ways to speed up reactions. However, if it's an enzyme, it's a catalyst. It's going to speed up that reaction. Okay, so let's break this down. What the heck is activation energy? And looking at this graph, all right, I'm going to zoom in here for you. All right, so looking at this, maybe I did that a little too big. Sorry, y'all. Okay, so what is an activation energy? Well, the activation energy is essentially the amount of energy required for a reaction to start or get going, okay? Think about the word activation, okay? To activate is to start, okay? This is just the amount of energy required for a reaction to get started, okay? And how does an enzyme speed up a reaction? Well, it speeds up a reaction by lowering or lowers the required activation energy, and it makes the reaction happen faster and easier. Let's look at this. There are two, you can see different lines here on this line graph, okay? And the y-axis is the energy, okay? The x-axis is the amount of time, okay? So I want you to think just about distance alone to begin with. Which one has more distance? This red one without the enzyme or this blue one with the enzyme? Yeah, the red one without the enzyme has to travel further. Therefore, it's going to take longer, okay? However, with the enzyme, you can see that that hump is much lower, okay? It's going to take less time overall. So here is the beginning of the reaction. So here are the reactants. Here are the products or what is produced. Here's where the magic is happening, okay? So again, reactants, what's going in. Products are what is coming out. Here's where the actual reaction is occurring, okay? So we already established that without the enzyme, it has to travel a further distance, so it's taking more time, okay? But notice what this hump represents, okay? This hump represents the amount of energy required for it to get started, okay? Or the activation energy. Do you see how without the enzyme, it has a much higher activation energy than with the enzyme? Okay, that's very, very, very important. So the activation energy is actually lowered with the enzyme. Without the enzyme, the active energy is much higher, okay? So how do enzymes speed up a reaction? Well, they lower this hump, okay? They lower the activation energy or the energy required to get the reaction started. And because of that, it can go a lot faster, okay? The other thing I want to point out here is notice how the reactants are higher than the products. They're higher than the products, okay? So what's going in is higher than the products. So do you think energy is being lost or is energy being gained? It's being lost, okay? We have more energy in the beginning than we do in the end. Therefore, energy is released. So if we're talking about exothermic versus endothermic reactions, exo means it's released or exited. Endo means it's brought in, okay, or introduced. So this would be an exothermic reaction because the reactants are higher than the products, or we are losing something. It is exiting. It's exothermic, okay? Now, if this hill went up like this right up here, that would be an endothermic reaction, okay? And that's what that's saying right here. Notice how the top of the hill on the reaction that uses the enzyme is lower. This is because less energy is required to start the reaction. So what would happen to chemical reactions without enzymes? Well, pretty easy. They'd slow down. Chemical reactions would slow down or maybe not even happen. If you have any questions, please, please, please make sure to reach out to your teacher. We are here to help you and support you. Thank you.